Yep. Hi guys. Good morning. All right. I think we can start. I'll do it here itself, just in case we need more space. I'll do it here. Should I just paste questions? I think I'll just paste questions in the room. Okay. Should we wait for people? I'll just a second, guys. What is the best way? Yep. Okay. Wait. This is in white. All right. Let's start. Okay. So this is 2018. All right. Right. So what is the first question? The first question, you have a sequence defined where you have a recursion given to you, right? So Tn is defined as Tn minus 1 plus 2n plus 1 for every integer. Then find the value of T20, right? So in general, whenever you have the difference of two consecutive terms given, what do? We go for the telescopic approach, right? So from here, we can write that two n plus 1, right? For every n greater than equal to 2, right? So now in this equation, if I plug n equal to, what do we need? We need 20, right? So if I put n equal to 20, I get T20 minus T19 equal to 2 into 20 plus 1. Similarly, if I put 19, what will I get? I'll get T19 minus T18 equal to 2 into 19 plus 1. All the way till what will be the last equation I'll get? If I put n equal to 2, I'll get T2 minus T1 equal to 2 times 2 plus 1, right? Now, if I add all these equations, you can see this gives you a telescopic sum, right? Yes or no? This will become a telescopic sum. This and this will cancel. 18 will cancel all the way till 2, right? So the only thing you'll have left on the left hand side is going to be T20 minus T1, which is 3, right? Yeah, T1 is 3. That should be equal to 2 into 20 plus 1 plus 2 into 19 plus 1. All the way till what is the last sum you're getting? You're getting 2 into 2 plus 1. So 5, right? So the right hand side is basically the sum of odd numbers. Yes or no? And what do we know about odd numbers? So if you look at the sum from 1 plus 2 all the way till sum 2n minus 1, right? If I look at 2n minus 1, this is the nth odd number. We know that this sum always turns out to be n square. Yes or no? So in this case, you have 5 all the way till 2 into 20 plus 1. But what is 2 into 20 plus 1? 2 into 20 plus 1 is nothing but 2 into 21 minus 1. Yes or no? This number is the same as 2 into 20 plus 1. So this is the 21st odd number, right? Now see, I have a few odd terms that I'm missing, right? So what should this entire sum be? Shouldn't this be 21 squared minus the missing terms, which is 1 and 3? Does this step make sense? I'm just looking for the sum of the first 21 odd numbers, but because I have 1 and 3 missing here, I have to subtract it as well, okay? So this part adds up to 21 square minus 4, okay? So coming back here, I can write this is equal to 21 square minus 4, which means T20 is nothing but 21 square minus 1. Send the minus 3 to the other side. 21 square is 441. 441 minus 1 is 440, right? So the answer is B. Is this clear? The first one. Any questions, anyone? Simple, right? Just going for this recursion sum, okay? Cool. Let's look at the next one. All right. The next one is you have, in some sense, a velocity function defined in terms of individual components of time, right? You have two different functions, phi1 and phi2, and based on that, you're defining the vector v, right? All right. So observe that first things first. All right. If I look at mod v is going to be this squared plus this squared divided by that, sorry, this one squared plus this one squared and the square root of that, right? Like we're looking at the magnitude of this. So phi1 squared t plus phi2 squared t and the square root of that, right? This is the magnitude of this velocity vector, okay? Now if I differentiate this, what is this going to be? This is going to be 1 by 2 root this thing times the derivative of this, which is twice of phi1 t, phi1 prime t plus phi2 t times phi2 prime t, right? So this is the derivative of the magnitude of this vector with respect to time. Yes or no? Does this stuff make sense to everybody? Okay. All right. And what is this quantity? It's nothing but the magnitude of the velocity vector. Yes or no? So from here, I can say that right? This is what we are getting. Yes or no? Okay. All right. Cool. And what else can I say? One second. If you look at the options, what do we have? We have some options which take care of the magnitude of this, and we also have this one other thing that we need to take care, right? So let's also look at what just dv by dt is. Dv by dt was just phi1 prime t I cap plus phi2 prime t j cap, right? So what is v vector dot dv by dt? The I components will multiply, so it's going to be phi1 prime plus phi2 prime, right? This is 1 and this is 2. These are the two equations we'll look at, okay? Cool. Now look at the options. Is dv by dt always equal to 0? No, right? Because phi1 and phi2 are not given to you. Yes or no? So we can't really say that dv by dt is always going to be equal to 0, right? Because this quantity might not always be 0. Phi1 and phi2 are two random functions, right? They're not given to us. So for every choice of phi1 and phi2, this quantity is not going to be 0, right? So option A can't be correct, right? What about option V? It's given that if v dot dv by dt is equal to 0, then what will we get? Okay. See, if v dot dv by dt is equal to 0, basically means this entire quantity is 0, right? Now, if this entire quantity is 0, this is 0. So, v dot dv by dt equal to 0 implies that mod v times d mod v by dt is equal to 0. Yes or no? But obviously, this quantity mod of v this can't always be equal to 0, right? It would depend on the values of phi1 and phi2, right? These are non-constant functions, right? So they can't always be 0, both of them at the same time, right? Which means which part has to be 0? This is not identically equal to 0, which means this is the part that has to be equal to 0. Now, if d mod v by dt is equal to 0, which means that mod v has to be a constant, right? Did this make sense? So the second option is correct, right? Because if this dot product is 0, we are getting that this derivative has to be 0, which tells you that mod v has to be a constant. So option B is correct, right? Similarly, look at the other way. If this derivative turns out, if mod v, what was option? Yeah, if this is constant, again, then this derivative is 0. If this derivative is equal to 0, then what would that mean? That this has to be equal to 0, right? And if this is 0, this dot product turns out to be 0. You understand? So the converse is also true. So option C is also going to be correct. And the fourth one is mod dv by dt is non-constant for any choice of phi1 and phi2. What is mod of dv by dt? Mod of dv by dt is phi1 prime square plus phi2 prime square, right? Is it for any choice of phi1 and phi2? It's not, right? See, if I choose my velocity to be a constant, what am I getting? If this turns out to be a constant, then that derivative will actually just be 0. Yes or no? From here itself. If this is a constant, this dot product turns out to be 0. V can't be 0, which means this derivative has to be 0, right? So it can't be non-constant for any choice of phi1 and phi2, right? For some choice of V, this actually turns out to be a constant. And that constant is 0, right? So option D is also incorrect. Okay? So the right answers are options B and C. That's 47. Hopes are clear to everybody. Question 48. What is question 48? The coefficient of x to the power 7 in this expansion is equal to the coefficient of x to the power minus 1 in this, then which of the following options is correct? What do we do? What is the general term in this going to look like? So what is the coefficient of x to the power k in this turning out to be? X to the power k would be given by the power of this rather. So it's going to be x to the power 2k minus of 11 minus k, so plus k minus 11, right? So that is just x to the power 3k minus 11. Similarly, in this other one, the general term looks like 11 choose k, ax to the power k is minus 1 by bx whole to the power 11 minus k. So the coefficient of x to the power k turns out to be x power k minus, sorry, this will be x square, right? Minus twice of this, so plus 2k minus 22. So that's x to the power 3k minus 22. Now, which are the ones you're looking for? We're looking for x to the power 7 in the first one, right? So if this is equal to 7, then what is the value of k from there? K will turn out to be 6, right? Similarly, in the second one, we want this to be equal to minus 1, which means k would turn out to be 7, right? So we got which terms they are, okay? Now we just need to look for the coefficients. First one, what will be the coefficient? 11 choose 6 times a to the power 6 times 1 by b to the power 5, right? Because if k is equal to 6, 11 minus 6 is going to be 5, right? So divided by b to the power 5, that should be equal to, on the left hand side, 11 choose 7, no, sorry, on the right hand side, a to the power, what will you get? 7, right? And b to the power, 11 minus 7 is 4. So minus 1 to the power 4 is plus 1. So it just turns out to be b to the power 4. So a power 7, b power 4, right? Okay. Now, you get an a from here, there's a b from here, which means ab is nothing but, so ab times 11 choose 7 is what? 11 factorial. So 11, 10, 9 and 8, 7 factorial cancels out, divided by 4 factorial. So 24, that should be equal to 8, 7 divided by 6 factorial cancels out, divided by 5 factorial, so 120, right? So 5, 11, 10, 9 cancels out, 8 also cancels out, right? So 7 by 5, right? So what is the value of the product? AB? 7 by 5. Okay. Which option is that? Option D. Cool, simple. Okay. Just look for the general term. Look which term gives you power x power 7 in the first one, x power minus 1 in the second one. Equate them, you get the relation between A and B. Alright. Cool. This is question 48. Going to question 49. Again, 49 is one of the easier questions in this paper. Right. This is, I think. Right. Okay. So what do we have? So we have ABC are distinct real numbers such that A square plus B is equal to B square plus C, and that is equal to C square plus A, right? So if I look at these two equations, what will I get? I'll get A square minus B square is equal to C minus B. See, we are looking for the values of A plus B, right? So what is A plus B going to be? That is going to be C minus B divided by A minus B. Yes or no? Similarly, if I look at these two, B square minus C square is equal to A minus C, which implies that B plus C is equal to A minus C divided by B minus C. And for the first and the last, you'll get that A square minus C square is equal to A minus B, which implies that A plus C is going to be A minus B divided by A minus C. Now what do you have to do? You just have to look at the product of these three ratios. So what are you getting? C minus B by A minus B times A minus C by B minus C times A minus B by A minus C. This and this cancels out, this and this cancels out. These two cancel out to give you a minus 1. That was the final answer. Option A, minus 1. That's it. Look for the terms that you have to find, the product of the terms that you have to find, express them in terms of the whatever else you have left, multiply them together, you get minus 1. That's it. Okay? Clear? Okay. Coming to question 50. Again, very straightforward. You have this function h(x) defined as f square x plus g square x, right? If I look at the derivative of h, what is h prime x going to be? 2fx f prime x plus 2gx g prime x. You can take this 2 common. Now look, f prime is given to be gx, right? So if I replace that value, I'll get fx into gx here. Similarly, in the second one, gx times what is g prime x? G prime x is minus fx. So this and this will cancel out, which means h prime x is equal to 0. If h prime x is equal to 0, this means that h is equal to some constant. Now if it's a constant, if at 1 it is equal to 2018, at 2018 also it's going to be 2018, right? So what is the answer? C. That's it. One liner, okay? Clear? All right. 51. All right, again, very simple question. You just need to see that you have 3 friends A, B and C who are drawing coins from a bag numbered 1, 2, 2 square, so on and so forth, all the way till 2 power 9. And what you want is find the probability that the sum of the numbers obtained by A and B. Suppose A obtains some number small a, same for B and C, okay? So you want this number A plus B to be equal to C. But you have to keep this in mind that these are all powers of 2, right? Every number that you're drawing is some power of 2, starting from 2 power 0 all the way till 2 power 9. Now it's very easy to show that 2 power k1 plus 2 power k2 cannot be equal to another power of 2. If you're adding to different powers of 2, okay, if you're adding to different powers of 2, you can never end up with another power of 2. Why? Because if you just look at this side, assume that k1 is greater than k2, which means if you take 2 power k2 common from here, you get 2 power k1 minus k2 plus 1. Now see, if k1 is strictly greater than k2, this is an even number. So even plus 1 is odd, right? So this entire number has some odd part to it, which is greater than 0. Can this ever be equal to a power of 2? No, right? It's some power of 2 times some odd number, okay? So you can't add two different powers of 2 and end up with another power of 2, right? This is the small observation that you had to make in this question, okay? Now, if I look at the option, which means the only way you can do it is if you add two identical powers of 2, and the double of that is C's number, right? So what are the possible pairs? A and B could pick up 1 and C and picks up 2, or 2 comma 2 comma 2 square, right? Or 2 square comma 2 square comma 2 cube, right? All the way till 2 power 8 comma 2 power 8 comma 2 power 9, right? These are the only possible triplets, okay? Clear? So how many such valid choices are you getting? You have 2 power 0 all the way till 2 power 8. So you have 9 possible triplets. And what is the total number of triplets you can pick? Everyone has how many options? 2 power 0 all the way till 2 power 9. So 10 choices, right? So what is the required probability? 9 divided by 10 into 10 into 10. This is the number of different triplets you can form. Yes or no? So what is the required probability? 9 by 1000, which is option C. Okay? Clear? Third question 52. Again, this is something you should know. When you take, I mean, you can come up with a counter example, but this is some fact that you should remember. When you take the union of two equivalence relations, what happens to the resultant union? Okay, is that also an equivalence relation, or what kind of relation that is? First of all, observe that, yeah, in this relation, if I look at R1 union R2, if I want to check whether it's reflexive or not, this number A, so these are both defined on some set S, right? Which means for any set A in S, we want A comma A to be present inside both R1 and R2, right? Because these are individually equivalence relations, right? So we know that A comma A belongs to R1 and it also belongs to R2, but we don't care about it. As long as it belongs to either one of them, it's going to be present in the final union, right? So I can say for sure that A comma A lies in R1 union R2 for every A inside the set S. Yes or no? So it's definitely going to be reflexive, okay? So that eliminates one option. It's not really useful for us, but anyways. Second one, whether it's symmetric. Now suppose you have A comma B present inside this union. For this to be symmetric, what do I want? I want B comma A to be also present, right? Now see, if A comma B is present inside R1 union R2, it means either it belongs to R1 or R2 or both. But it has to be present inside at least one. But see, because R1 is an equivalence relation, if it's present inside R1, then B comma is going to be present inside R1 as well, right? Similarly, if it lies in R2, B comma has to lie inside R2. Because what? R1 and R2 are individually equivalence relations, right? Which means no matter what, B comma A is definitely going to lie inside their union. So it's also symmetric as well, right? So far we have that it's reflexive and it's also symmetric, right? Now the next part is we need to check whether it's transitive or not. But remember, it should be kind of intuitive that it can't be, I mean, you can always construct something when it's not going to be transitive, right? Why? Because see, there is a chance that A comma B comes from the first relation. You have some B comma C coming from the second relation, and the final A comma C does not belong, right? Your intuitive sense should tell you this much, that you should be able to construct a counter example for that, right? And I'll give you a counter example if you want a rigorous one. But you understand, like, it's easy to construct a counter example, okay? So let's say take the set S to be 1, 2, 3. Define R1 to be obviously 1, 1, 2, 2, 3, 3. And then let's take 1, 2, and 2, 1. Okay, this is an equivalence relation. Again, 1, 1. And now let's take, say, 1, 3, and 3, 1. So what is the union going to be? The three, I mean, the natural triplets, the 3, 1, 1, 2, 1, 3, 3. Apart from that, you have 1, 2, 2, 1, 1, 3, and 3, 1, right? Now see, 2, 1 lies, 1, 3 lies. If it had been a transitive relation, you wanted 2, 3 to be present as well, right? But 2, 3 is not present in this, right? So this is an obvious example where R1 and R2 are equivalence relations, but R1 union R2 is not. Okay? So it can't be an equivalence relation. So it's symmetric and, sorry, reflexive and symmetric, but not transitive. So option D. Okay? Cool. Coming to question 53. Okay, again, what do we do here? King's property, right? So I if I replace it with a plus b is 0, right? So I replace this with minus x, right? So mod of minus x is again mod x divided by 1 plus e power minus x. So if I add these two, what will I get? 2i should be equal to integral minus 1 to 1 mod x. What is this? This is e power x by 1 plus e power x. And this entire thing goes to 1. Yes or no? So what is the value of 2i? 2i just turns out to be integral minus 1 to 1 mod x dx. Now you can solve this whichever way you want. Okay, if you want, you can use the fact that this is twice of 0 to 1 mod x dx, which implies I is just this integral. And what does mod look like? 0 to 1, it's just this triangle, right? So what is this integral going to be? It's just half. Okay. Or you can just see that between 0 and 1 mod x is just x. Okay, so that's integral of x between 0 and 1, which is half. Okay, as simple as that. Okay. The answer is B. Cool. Let's look at the next one. 54. Okay, 54 is slightly lengthy. Let's do this later. It's just brute force. Let's do 55 first. Right. So you have a functional equation given to you from rationals to integers. Okay, this is important. It's from rationals to integers. Such that f of x plus y is equal to fx plus fy. Now you should know what kind of a function does this give you. This gives you some fx equal to some cx function, right? The solution of this is fx equal to cx. Okay. Now in this case, it's given that, now see, the c is in general a constant, right? What is c? C is nothing but the value of f of 1. So this is a constant. Now, it's given that it maps every rational number to an integer. If you look at all these values cx, where x is purely rational, okay? This can't always be an integer, right? Because at some point you will find some x for which this quantity is no longer an integer, right? So for this quantity to be an integer for every x, the only possibility is you want c to be identically equal to 0. If it's not, you can't force every rational, you can't force a value of every rational number to become an integer, right? So this is only going to be possible if c is identically equal to 0. Do you understand? Does this make sense? I mean, I can do it more rigorously. I mean, you can just take the prime factorization of c if you want. Right? It only has some finitely many primes, right? So if I take any prime outside this, okay, if I just take x to be 1 by the next prime, let's say pk plus 1, then c into x is no longer an integer, right? Do you understand? That's the point. So as long as you choose any finite c, I can always come up with some value of x such that cx is not an integer, okay? Which means the only way this will be possible if c is identically equal to 0, and if c is identically equal to 0, our function itself becomes identically equal to 0. So how many such functions are you getting? Just one. So answer B. Clear? Slightly conceptual if you think about it, but not very difficult, okay? All right. 56. Right. So you have the product of two quadratics given to you where p and q are integers. This is an important part. P and q are integers and two of the roots are given, 2 plus root 3 and 1 minus iota. So we know that this overall polynomial, this overall thing, this is an integer polynomial, yes or no? This is a symbol for integer polynomial, okay? And for an integer polynomial or even for a real polynomial, we need integer for this part. What do we know for an integer polynomial? We know that if one of the roots is an irrational, the other root has to be its conjugate. Same for complex, which means I know the four roots of this, right? It's going to be 2 plus root 3, 2 minus root 3, 1 minus iota, and 1 plus iota. Now, which quadratic has which of the roots? Can I pair this with either this or this? If I look at the roots of the first part, can I pair 2 plus root 3 with either 1 plus iota or 1 minus iota? No, right? Because if I multiply these two, this polynomial or this polynomial will have complex coefficients, which is not allowed, right? Which means the only way you can pair these roots are you want to pair them with their conjugates, which means these two are the roots of one of the quadratic, these two are the roots of the other quadratic. Now look at the sum of these two and the product of these two. The sum is equal to 4 and the product is equal to 1. For these two, the sum is equal to 2 and the product is also going to be 1 square minus 1 square, so 2, right? Now if you look at the two quantities given to you, we know that the roots of this should add up to 2, right? Which means this part, so x square minus 2x plus q equal to 0. The roots of this are equal to 1 plus iota and 1 minus iota, right? Because the sum of the roots of this quadratic is equal to 2. Similarly, the roots of x square plus px plus 1 equal to 0. This should have roots 2 plus root 3 and 2 minus root 3. Because now see, the product of the roots is given as 1. And only these two numbers multiply to give you 1, right? So we identified which quadratic has which roots, right? Now find the value of the unknowns. P is what? Minus the sum of this. So P is going to be minus 4. What is Q? Q is the product of these two. So Q is going to be 2. So what is the value of P plus Q? Minus 2, right? That's it. See, that's the thing. Once you understand the idea, once you are able to correlate all these ideas, you don't really have to do a lot of work, okay? Even though it's a next question, it's still a one-page question, okay? It's not lengthy, it's not difficult, okay? You just need to figure these out. We have studied all this, right? That if you have a real polynomial, then complex roots occur as conjugates. If it's an integer polynomial, irrational roots occur as conjugates, right? Then you have to figure out we can't pair this irrational with this complex, right? Then the final quadratic won't have integer coefficients. That's it. So two steps that you have to think about. So that's 56, okay? 57. Okay. Again, 57. What do we have? So you have a function f which is given to you and another function g that's given to you, right? All right. So if I look at limit x going to 0, there should be limit x going to 0. Now see, g is continuous at x equal to 0, which means limit x going to 0 gx is nothing but g0, whatever that is. So this overall thing turns out to be 0 to the power k times g0, which is 0, right? So f is continuous at 0 and it's equal to 0, right? If I look at f prime, what will I get? I get x to the power k g prime x plus gx times x to the power k times x to the power k minus 1, right? Okay. Okay, we have done one such questions in 50 important questions, right? Even if I don't know whether G is differentiable or not, I can write this part as right. Even if I don't know whether G is differentiable, I mean, I'm just generalizing it. Even if I don't know that G is differentiable, I can write G prime as this limit, right? But now observe that. What do we need? We need f prime 0, right? If I look at f prime 0, see x to the power k, as long as, no matter what k is, what was k? K is a positive integer, right? Which means this part will always be 0. So what is f prime 0 going to be? It's going to be g0 times k times x to the power k minus 1. Sorry, 0 to the power k minus 1. Which is going to be 0 for all k greater than equal to 2. But it's going to be equal to what? If k is equal to 1, what will I get? If k is equal to 1, this basically becomes 1, right? So what are you getting? G0, right? Which is that option? It's option D, right? F prime 0 is going to be G0 if k is equal to 1. And f prime 0 is 0 for all k greater than equal to 2, right? So option D is definitely correct. Now let's look at the other options. For the other options, observe that f is differentiable at x equal to 0. Yeah, that should also make sense, right? Because this part is not contributing anything, right? K is a natural number, which means this will always be 0, even if this limit does not exist, right? You understand? This is always going to be 0, which means only the second part decides the differentiability of f, okay? And this is what? This is a finite value, right? So f prime x does exist, right? This quantity exists for every value of k, yes? So f is differentiable at x equal to 0, right? F is continuous but not differential, that's obviously not correct. C is also not correct. So these are the only two options, right? So it's B and D. Cool. Okay. So this was question 57. Coming to question 58. Yeah, okay, again, easy question. Let's do this one. So you have two complex numbers given to you, which are of unit modulus, which means I can write down Z1 as what? Some cos A plus I sin A. And I can write Z2 as yes. Which means if I relate it with the values given, cos A is equal to cos A, B is equal to sin A, C is equal to cos B, D is equal to sin B. It's also given that the real part of Z1 times Z2 conjugate is equal to 0. What is Z1 times Z2 conjugate? Sorry, real part of this, right? The real part of cos A plus I sin A times cos B minus I sin B. This quantity is 0. What is the real part of this? Cos A cos B and the complex parts multiplied together. So minus I square will become plus. So my plus sin A sin B. That is equal to 0, which implies cos of A minus B is 0. So I can write A minus B is equal to 90, right? Okay. Now from here, let's find out the values of, let's find out the values of this in terms of the other one, right? So A is nothing but B plus 90. Okay. A is equal to B plus 90. So what will be the value of cos A? Cos A cos B minus sin A sin B, right? Okay. Cos of A plus B is cos A cos B minus sin A sin B. So A turns out to be minus of sine of this, right? Yeah. So cos of A will be cos A cos B, that becomes 0, minus sin A sin B. So minus sin B. And sine of A is sin A cos B plus cos A sin B. So cos B, right? So what can I say from here? What was cos A? Cos A was A, right? So A is equal to minus of sin B was D. So A is equal to minus D and sin A is cos B, right? So B is equal to C. This is what I'm finally getting, okay? Now let's look at W1 and W2. Here one is A plus IC, so that's minus D plus IC, right? And W2, I'm taking everything in terms of C and D, okay? B is C, right? So C plus ID. Now, obviously from here we can say that W1 mod of W2 is nothing but square root of C square plus D square, right? These two are the same. So option 1 is definitely correct, right? Real part of W1 is equal to imaginary part of W2. Is that correct? Real part of this is equal to imaginary part. No, right? They have opposite signs. Yes or no? So B is incorrect, right? Yeah. Real part of W1 times W2 conjugate. What is W1 times W2 conjugate? Minus D plus IC times C minus ID. That turns out to be minus CD. And we are only interested in the real part of this, right? That will turn out to be minus CD minus I square, so plus 1 plus CD, right? So that turns out to be 0. So this is correct, right? So option C is correct. Real part of W1 times W2. What will that be? Minus D plus IC times C plus ID, right? That is minus CD minus CD. So that's minus 2 CD. And what is the real part of W1? Minus D, right? So this is twice of real part of times C is real part of W2, right? So option D is also correct, okay? So the answer is ACD. Okay? Simple. All you have to do was figure out this big difference between A and B, okay? The arguments of these two complex numbers. 59. You have a parabola given where there is a variable A, okay? Right. So, what is the vertex of this parabola? So, it's something y equal to x square plus 2ax plus a, right? So, what is the x coordinate of this vertex? It's minus b by 2a, right? When you have some ax square plus bx plus c, what is the x coordinate of this vertex? It's always minus b by 2a, right? So, in this case, it's going to be minus 2a divided by 2. So, that's minus a. And value of y is going to be a square plus a minus 2a square, right? That's going to be a minus a square. Right? Yes or no? Did I make a mistake? Yeah, this is what you'll get, right? Yeah, okay, cool. Fine. So this is the vertex of PA, right? Can we get any vertex? The vertex of parabola PA lies on the line x equal to minus a. So option C, we are directly getting it from here, right? Okay. Locus of the vertex of PA is a parabola whose vertex is minus half comma 1 by 4. So you want to find the you want to find the locus of this, right? So if I take h equal to minus a, right? What am I getting? That k is, this is going to be minus h minus h square. So what am I getting? We are getting that y equal to minus x square. That is minus of x plus half whole square plus 1 by 4. You know this, it's a very standard factorization, right? So this is the parabola that you're getting, right? What is the vertex of this going to be? Minus half comma 1 by 4, right? So the locus is indeed a parabola whose vertex is minus half comma 4. Alright. Now the only parts are remaining. Is there a common point which lies on PA for every value of A? Okay, so no matter what A is, you want to find a common point. Easiest way would be just find some point that lies on this, okay? You see, if you put x equal to, if you look, this was given in the question. If you had just plugged this into this, you would have gotten the answer. If you put x equal to minus half, what will happen? You'll get y equal to 1 by 4 minus 2a. So 2 and 2 cancel out, so minus a plus a, right? So that's 1 by 4. So this point, this is the common point that lies on this, okay? This parabola for all values of a. And if you want to simplify it further, you can see that for this to have a general solution, you want the coefficient of a to be 0, right? So if you treat this as this, so you get x minus y minus x square is equal to a times x plus, sorry, 2x plus 1. Okay. So if solutions of this, what is the meaning of finding a common point? You want to find solutions xy, right, which are common to all the parabolas. So if it's common, it means that the part involving a should be 0, right? Which means this has to be 0. So x has to be minus half. And once you get x equal to minus half, plug this here, you'll get the value of I as well. Okay, that's the way. Or you could have just plugged this value and checked it. Okay. So there is a common point, and that point is nothing but minus half comma 1 by 4. Okay. So the answer is ACD. Cool. Question 59. Question 60. Okay, this is also nice. This is a nice question. First things first. One of the options is obviously correct, right? Sine, this is, call this some theta. So this is nothing but sine theta, Cn is nothing but cos theta, right? So sine square theta plus cos square theta is always 1, so option A is definitely correct, right? Now, coming to the next thing. Look at this, x naught is a positive real number, right? So if I use AMGM on this quantity, I know this is greater than or equal to twice of x naught to the power n, which means if I cross multiply, I can say that x naught square to the power n divided by 1 plus x naught whole to the power 2n is less than or equal to half, which means pi times x naught to the power n divided by 1 plus x naught whole to the power 2n is always going to be less than or equal to pi by 2. So which means the angles that you're working with for both the sequences, these angles lie in the first, not in the first quadrant, between 0 and pi by 2. And between 0 and pi by 2, what is the nature of the two graphs, sine and cos? This is what sine looks like, this is what cos looks like, right? So sine is increasing, right? Sine is increasing in this, yes or no? Okay, does this make sense? Right. So if sine is increasing, what can I say about theta? 1 second. 1 second. I need to find a relation between these angles as well. If you look at this, let's just look at this angle. Pi is a constant, forget about it. So x naught power n by 1 plus x naught power 2n, right? Yes. If I call this a function of n, can I check whether this function is increasing or not, or whether it's decreasing? What would be the easiest way of doing that? What is the reciprocal of this? And you can always differentiate it, but I'm trying to find an easier way. This is 1 by x naught power n plus x naught power n, right? This is what you're getting, okay? This is going to be easier to differentiate this now. So let's look at this function as gn, okay? The power, it's just going to be the same quantity times log of x naught, right? One sec. log x naught, right? Base e. So it kind of depends on what the value of x naught is. It's not going to be universally true. Then you also have a pi with it, right? This is pi x naught. But doesn't matter. It's just some constant. It's common. Just a second. I want to check whether these arguments are increasing or decreasing because we need that. Otherwise, we can't predict the nature of sine and cos. Let's just prove that it's decreasing. Will it be decreasing? One sec. Suppose I claim this. Okay. Send this, bring this to the side, so you get x naught power 3n plus 1 times x naught minus 1. You want this to be true, right? Yeah, we can't really make a prediction. See, if it's equal to 1, then obviously equality is going to be holding for all the numbers, so forget about it. Otherwise, we want x naught to the power 3n plus 1 to be greater than x naught. This is only true if x naught is greater than 1, otherwise it's not. We can't really make a prediction whether it's decreasing or not. The same thing we got for log. We got that log component, right? So depending on whether x naught lies in between 0 and 1, or whether x naught is some other number, okay? If it's greater than 1, you get a different value of log. If it's less than 1, you'll get a different value. Same for here, okay? This is going to be true if and only if this is true, right? But we are only getting this. So x naught to the power 3n plus 1 is greater than x naught if and only if x naught is greater than 1, right? For fractions, this is obviously not true, right? So that's the thing. So we can't really make any prediction about this. See, Sn greater than Sn plus 1 is basically saying that this is going to be decreasing. Only if this is decreasing, this is true, okay? Otherwise, it's not. Same goes for cosine. We can't really make any prediction about it. Same for tan. This is nothing but the value of tan of, let's call it theta n maybe. You can't make any predictions about B, C, and D unless and until x naught is defined to us. X naught is just positive. We can't really make any prediction about these. One second. I just draw the. I think we can draw the graph and check once. So we want x to the power n. Let's just take. Oh, we want some constant. Okay, let's go with some constant. Okay, let's check for integer value. Let's go with 2. Okay, so 2 power x. 2 power x divided by divided by 1 plus 1 to the power 2x, right? Yeah, as you can see, for over here as well. So for this is decreasing, right? Okay, for this is decreasing, okay, clearly. But if I draw for another one, let's go with a fractional, let's go with half, okay? So half is going to be just minus of that, right? So I go with half, so it becomes 2 to the power minus x, right? Divided by Wait, what will I get? I'm going with half, right? So it's going to be half to the power x. Right? So multiply it. So you get 2 power x by 1 plus 2 power x, right? 2 power 2x. Wait, it's exactly the same thing. We're ending up with the same thing. Oh, wait. Can I use this argument for doing this? See, isn't f of x naught the same as f of 1 by x naught? When I replace x naught with 1 by x naught, I end up with the same thing, right? Yes or no? Which means even we know that it's going to be increasing for x naught greater than 0, right? Sorry, greater than 1. We know this. But f of x naught is equal to 1 by f of x naught, right? Which means even if I have a number that's a fraction, I can just replace it with 1 by x naught. So if it's increasing for greater than 1, it should also be increasing for numbers less than 1, right? Yeah, okay. This argument works. Okay, we just needed this. Fine. So we get this, okay? Fine. So this function is always decreasing, okay? This theta n is decreasing. Now, let's come back to this. So if the value of theta n decreases, what will happen? Sine will also decrease, right? Because sine is an increasing function, right? Sine is an increasing function in the first 0 to pi by 2. Which means if the value of your theta decreases, sine is going to decrease, right? So sine n is going to be greater than equal to sine of n plus 1. Okay? So that's the first one. So this is true. Option C, cos. You can see that cos, this theta n again is decreasing, but cos theta itself is decreasing, right? Which means if you decrease the value of theta, cos theta should increase, right? Which means Cn plus 1 should be greater than equal to Cn. So option C is incorrect, right? So Cn can't be greater than equal to Cn plus 1, okay? Cn is less than equal to Cn plus 1. Turn to the last one. What is Sn by Cn? Tan of theta n, right? Again, tan is an increasing function, which means if theta n is decreasing, tan is going to be decreasing as well, right? So D is also correct. So it's going to be A, B and D, alright? Fine? Cool. Fine. Sorry, I got a little stuck at this part. Anyways, we left one question, the geometry one. Let's do that now. All right. So we'll basically use coordinate bash for this one, okay? So if I write this as 0, 0, let's say length of the rectangle is L, this gives you L, 0. This will be some L, B, this is going to be some 0, B, right? Which means this midpoint M is nothing but L by 2, 0. Yes. What is O? O is the midpoint of the diagonal, right? So L by 2, B by 2. So we get these two, right? Now, we can find the points x and y as well, right? Because I can find the equation of this line MB. What is the equation of the line MB? MB is given by y minus y1. You can go either way. Y minus y1 equal to y2 minus y1. Let's go with y minus y1 equal to y2 minus y1 divided by x1. So 2b by L x minus L by 2, right? This is the equation of the line MB. Similarly, you can find the equation of the line AC, right? AC is going to be what? AC you can directly find, right? It's the slope intercept form, right? I mean, sorry, it's a 2 intercept form. It makes an intercept of L on the x-axis, it makes an intercept B on the y-axis, right? So x by L plus y by B equal to 1, okay? Now from these two, we can solve and find the point of intersection of these two lines, which is nothing but y. So we solve, you'll see it turns out to be 2L by 3, comma B by 3, okay? Same way, you can solve for these two, right? You can solve for DB and MA, okay? So if you do that, you'll see it turns out to be L by 3, comma B by 3, okay? So you basically get the coordinates of all the points, right? Now if you have the coordinates of all the points, we can find out the area, right? We know how to find the coordinate we know how to find the area of any polygon, right, in coordinate geometry. If we have the coordinates given to us, yes or no? Right? One second. So I'll write down the general form for you. So that turns out to be. So the way you do that is, so in general, suppose you have a polygon, okay, which has n points. I'll give you the general form. So suppose you have P1, which is x1, y1, all the way till some Pn, which is x and yn, okay. So these are the points, okay. So follow an order, okay, otherwise you'll mess up the sign, okay. So label it clockwise or anti-clockwise, whichever one you want, doesn't really matter, but make sure you do it in a sequence, right? So the way you find the area is, it's going to be half the value of this thing, okay. So what you do is, write down all the coordinates, right? So x1, y1, x2, y2, x3, y3, all the way till x and yn, depending on the number of points, and then write x1, y1 again, okay. So you complete all the points and then you write x1, y1 again. Make a table like this. What you do is, you cross multiply them diagonally, kind of like solving for 2 cross 2 determinants, okay. All the way till here, right? So what are the values you are getting? So you'll get x1, y2 minus x2, y1 plus x2, y3 minus x3, y2, right? All the way till x and y1 minus x1, yn. Look at this entire sum. Take the absolute value of that divided by 2. That is your required area, okay? So if I call this sum S, then your required area is half mod S, okay? This is a general formula for finding the area of any polygon which has n sides and if you know all the coordinates, okay? Clear? So that's what you have to do in this question after this. For example, which one is the first one we are looking for? You want to find the area of, so it's all about AOX and OXMY, right? So AOX, let's use this form, okay? So see, A, B, C, go in that sequence, okay? What was A? B was L comma B, C was, this was B, A, B, O, right? Sorry, we want A, O, X. Actually, we want A, O, X, sorry. O was L by 2, comma B by 2, X is L by 3, B by 3, right? Let's look at the value of this, okay? So what do we do? 0, B, L by 2, B by 2, L by 3, B by 3, and then 0 and B again. What are you getting from the first one? BL by 2 plus BL by 6. This is also going to be BL by 6, right? So difference is going to be 0. This is going to be BL by 3. Right? This is what you're getting. Okay. Right, did I make any mistakes? BL by 2, BL by 6 minus BL by 6. Okay, that cancels out. That is BL by 3. Okay, this is what you're getting, right? That's going to be 5 by 6, right? How about that? So this is what you're getting. Okay. Right. 1 second. Sorry. This should have been a minus. Yeah, my bad. Yeah, I mean, this is going to be 0. This is minus, right? So this is what you're getting. So that's nothing but BL by 6 here. Yeah. My bad. Okay. So what is the final area of this? So area of A of X, this turns out to be BL by 12, right? That's one. What is the other one you want to find? OXMY, right? So OXMY, fine. O is L by 2, B by 2. X is L by 3, B by 3. M is L by 2, 0. Y was 2L by 3, B by 3. What do you do? Again, write them. And the first one again, right? So L by 2, B by 2. What are you getting? These you cancel out again, right? BL by 6, BL by 6. 0 minus BL by 6, first one, right? From here. Then the next one is going to give you plus BL by 6. This one is going to give you plus 2 will cancel out. So BL by 3, BL by 6. So that turns out to be 2. So that's again BL by 6, right? So what is the area? 2BL by 12, right? Sorry, just BL by 12. Yeah. So you can say that the areas of these two are equal, right? So which one is that? Area of these two are equal. And these are equal for any L and B, right? There's no restriction on ABCD to be a square. You understand? We did not get any conditions on NLB, right? For any L and B, these are equal, right? So it's not going to be option C, it's option D, right? So that's your answer. Cool. So remember this one, okay? Remember this formula. This is a very nice. Okay, and this is sometimes it's even easier than remembering that formula for finding the area of a triangle. Okay, I mean that determinant can also be derived from here, but you can also use this to find the area of the triangle. Okay, sometimes it's faster. Okay, cool. So that takes care of this NEST 2018. Hopefully you don't have any questions. And if you have, you can ask. Any questions, anyone? If not, that'll wait. See you guys. Bye bye. Yep. Bye guys.